Hey, welcome back to Math with Patrick. Today is November 19th, and we're solving problem 323 from the Daily Epsilon calendar. And today, we should show why x is 19, because that's today's date. So, we are told that y is equal to the difference between pi and this kind of weird square root number here. And once we figure out what y is, we're going to multiply it by 321,000, and supposedly we'll get 19. So initially, this problem looks really weird. Like, why are we subtracting these two numbers? And then why are we getting a number that's so small that when we multiply it by something so big, we only get 19? The idea here is that this number is actually a really strong approximation of pi. And I actually want to talk about it a little bit before we actually do the problem for today. This is called, I might be mispronouncing the name, but Kochanski's approximation. I think he was a Polish mathematician from the 17th century, as in I looked him up before this. And apparently, he came up with this geometric strategy to approximate pi. The idea starts with a unit circle, and then we can get some kind of tangent line base for a unit circle. And if we leave the unit circle, the center of the circle at an angle of 30 degrees and line ourselves up with that base, and then finally move 3 units to the right, not finally, and then connect the top of the circle with this point right here, we apparently get a good approximation for pi. Now let's try to Pythagorean theorem this triangle and see if we can replicate this value right here. So zooming in here, we have a unit circle. That means that this length right here is 1. It's a 30, 60, 90 triangle. And so to go from this length to that one, we just need to divide by root 3. So we would get something like 1 over root 3, although just to rationalize the denominator, I will say that this is root 3 over 3. This is going to the left, and so it's negative root 3 over 3. And once we go to the right by 3 units, we can take a look at this length right here and label that as 3 minus root 3 over 3. And then the vertical distance isn't too hard to compute. It's just twice the radius of the unit circle, so 2. And then we can Pythagorean theorem this right triangle, see what we get. We should get c squared is equal to a squared plus b squared. One of our legs is just 2, so squaring it gives us 4. The other leg is that number that we computed here. A little bit harder to square. Let's just see what happens. We'll do first times the first. And then once we do twice this product right here, that times 3 and divide by 3 go away. So we get minus 2 root 3. And then multiplying this by itself, we do get a positive 1/3, I believe. Let me just double check, right? Because we have root 3 times root 3 on top, 3 times 3 on bottom. Nice. And that simplifies to 1/3. And I don't really need these parentheses anymore, I guess, on the right side. And this is still all equal to our hypotenuse squared. Let's combine our like terms. We get 13 and 1/3. And then minus 2 root 3. We can change this mixed number into an improper fraction. I see 39 plus 1, or 40/3. And then let's hit both sides with a square root to finally get our value for c. And what do you know? This is precisely the expression that we have at the beginning of the problem. Now, there's nothing in the diagram that really says why this is an approximation for pi. I don't think there's anything geometrically that suggests that this needs to be anything close to pi at all. I mean, it's kind of the same like looking-ish length as this curve right here, and that curve does have the length of pi exactly. Anyways, I wanted to show you at least where the value comes from in a geometric sense, also a historical sense. I looked it up again. The name is pronounced Kochański instead of Kochanski, so Kochański, I believe. And anyways, there really isn't any good way for me to solve this by hand. So let's just hop on over to like a calculator and see what happens. So here's that square root value, just written kind of with like plain text. Let's look it up first. So here is that expression that we're more familiar with the square root sign. Here we can see the decimal approximation for that number, 3.14153. And so it differs from pi starting with the fifth decimal place. And so once we do pi minus this number, whoops, that isn't minus. Once we do pi minus this number, we're going to get a whole bunch of zeros. And then finally, we have some error term over here. And so we can see what happens when we finally multiply this value by 321,000, and we should get 19, or approximately 19. And what do you know? It's 19.04. And since the problem said to approximate, it's totally fine that we have some kind of weird decimal running on indefinitely. But the answer is 19, and today is the 19th, so it all matches. So thanks for watching. We're all done. I'll see you tomorrow. Bye.